Hi everyone. So we are going to take a quick look at how we work with finding special polynomial products. And you can see below here how we have a few different products that we're going to learn the patterns of how to write out their products. So we have binomial squares. These are binomials that are raised to the second power, so we're squaring them. And then binomial cubes. These are binomials that we are raising to the third power. So let's take a quick look at just what the patterns look like. In the first grouping, binomial squares, we have first the square of the sum, binomial sum. That would be a plus b. So this means that we are taking a plus b and multiplying it with itself, a plus b. So two binomials that would be multiplied together. The product pattern is a squared, the a term squared, plus 2 times the product of a and b, the a and the b term, plus the b term squared. And then, of course, if it's a minus b, if you have subtraction in the binomial and you're squaring it, then its product would look like this, a squared minus 2 times ab plus the b term squared. We're going to talk a little bit about why these patterns are what they are. Binomial cubes look a little bit different. There's obviously going to be a little bit more going on because we are taking the binomial and cubing it. So in this case, we would take a plus b and multiply it out 3 times with itself. So its product would be a cubed, the a term cubed, plus 3 times the a term squared times the b term, plus 3 times the a term times the b term squared, plus the b term cubed. And again, we have an a minus b as well. This would be a minus b multiplied out 3 times. The pattern looks a little bit different. It's similar, but a little bit different. A cubed minus 3 times the a squared b plus 3 times the a b squared minus the b cubed. We have some subtraction in here because, of course, we're multiplying a binomial that has subtraction, just like up here the binomial that had subtraction in it had some subtraction in its product as well. So let's move on. Let's look at binomial squares. We have a plus b, the quantity a plus b squared. We know this is its product pattern, so let's talk about how and why it becomes that way. We have a plus b squared, which really means that we're taking a plus b and multiplying it again with a plus b. So if you use distribution, then using the FOIL pattern that most of you like to use, we would start with a times a, giving us a squared. Then we would multiply a times b, which would give us the ab term. Then we would multiply b times a to give us another ab term. And then, of course, we would multiply b times b to give us the b squared term. When we move on, we see that we have 2 like terms here that can be combined to give us the 2ab here in the middle. So this, in fact, becomes the product of a plus b, the quantity squared. So we can say that the quantity a plus b squared is equal to a squared plus 2 times ab plus b squared. Let's take a look at what this looks like with an actual binomial that isn't just a plus b. We've got n plus 7 here, the quantity squared. We're going to say that the a term is n and the b term is 7. So we're going to replace the a with n and the b with 7 and move on from there. So here's our pattern. We have the a term is now replaced with n. The b term is now replaced with 7. So that means that when we have the a term squared, that's really going to be n squared. Then we have 2 times the ab, so that's 2 times their replacements, which are n and 7. And then the b term squared, which is really just 7 squared. When we do all the math here, we'll see that we get n plus 7, the product squared, the product of n plus 7 squared is n squared plus 14n plus 49 when we do all the simplifying. So let's take a look at how this works out when it's a minus b, the binomial a minus b squared. We get this pattern of a squared minus 2ab plus b squared. And the reason we get a minus 2ab is when we multiply a times this b, we'll get a negative ab. This negative b times this a will give us another negative ab. So the like terms will give us a negative 2ab. So we have another example to look at. and that is 6x minus 3, the quantity squared. So we are going to replace a with 6, it's supposed to say 6x here, and b with 3, and work out this pattern. So we have a minus b squared is equal to this pattern, so 6x minus 3, the quantity squared. So we take the a squared term, and of course a is replaced with 6x, that will be squared. Then 2 times the a times the b, so it's actually negative 2 times the a term, which is 6x, times the b term, which is 3. And then, of course, the b term squared, which is 3 squared. So in the end, what we will get is 36x squared minus 36x plus 9. Okay, let's move on to binomial cubes. This one's a lot more fun because, of course, there's a lot more multiplying. So now we're looking at the cube of a binomial. And here's its product pattern. What we're doing when we're cubing a binomial is we're actually multiplying it out 3 times. So that means that if we're multiplying it out 3 times, notice that the first 2 a plus b binomials that are getting multiplied are really just a plus b squared, which is the pattern we just learned. So I'm actually squaring a plus b and then multiplying that square with another a plus b. So we can use the pattern of a plus b, the quantity squared, and multiply its product with a plus b. So the product pattern of a plus b squared is here, a squared plus 2ab plus b squared. This is the pattern we just learned when we're squaring an a plus b or a binomial. And we're going to distribute it with a plus b. That's the third of these binomials that we're multiplying through. So that means that if I take this trinomial and distribute it, I'm going to do a squared times a to get a cubed, 2ab times a to get 2a squared b, and then b squared times a to get the ab squared. Next we will multiply a squared times b, that gives us this a squared b, then 2ab times b to give us the 2ab squared, and then b squared times b to give us the b cubed. I have now distributed all 3 of these terms over the a and the b. I'm going to look for some like terms. Here they are. The 2a squared b can be added with the a squared b here, and the ab squared can be added with this 2ab squared. So when I combine my like terms, I get my final product pattern, which is a cubed plus 3 times a squared b plus 3 times ab squared plus b cubed. Okay, so we're going to take a look at how this pattern works with a different binomial that we're cubing. So here we go. We've got 2 plus x, the quantity cubed. We're going to replace the a with 2 and the b with x, and we're going to plug it into this pattern, which hopefully you've written down by now. So let's take a look at how this works out. So we've got our a plus b cubed. The pattern is right here. I'm just going to replace the a's with 2 and the b's with x. So again, a is 2, b is x. Let's see how it works through the pattern. So we've got the a term cubed, which is 2 cubed, 3 times the a squared times the b, 3 times the a term times the b term squared, and then we have the b term cubed. And again, all I'm doing is replacing the a's and b's with the 2 and the x, and then I'm going to work out the product by simplifying. So we've got 2 cubed is 8, 3 times 2 squared x is going to be 12x, 3 times 2 times x squared is going to be 6x squared, and of course x cubed is x cubed. So this is our product. Let's move on to binomial cubes with subtraction. The pattern is a little bit different. I have in my second term, instead of a positive 3a squared b, it's going to be minus 3a squared b. And then our final term, when we're cubing, if you're cubing a negative, technically you're going to end up with a negative, so that's minus b cubed. You can see how this all works out here when we do a minus b squared. Again, this is the product pattern for a minus b squared times a minus b. So this trinomial would get distributed with a and negative b to get the final product here. Let's replace a and b with terms from another binomial that we're cubing. So a is 8k and b is 7. So a is 8k and b is 7. This is one where you're going to probably need to use a calculator to simplify your answer. Just going to tell you that right now. So let's write out the product pattern and start replacing our a's and b's with 8k and 7. So a is 8k and the b term is 7. So we know that a cubed is really going to be 8k cubed. Then minus 3a squared b is really going to be minus 3 times the 8k squared times the 7. And then 3 times the 8k times the 7 squared. And then finally minus the 7 cubed. All right, I need definitely to use a calculator when I'm working this out. So the first term is going to be 8, the quantity 8k cubed, which gives us 512k cubed. This one's fun because you have to square the 8k first. So you're going to get 64, multiply that by the negative 3 and the 7, and so you'll get a negative 1,344k squared. Here you want to make sure you're squaring the 7 first, and then multiplying that with 8 and 3 to get 1,176k. And then, of course, 7 cubed is 343. Bottom line, you need to write down all of these patterns and try your best, well, they're very similar, but try your best to memorize them. Now, if these patterns don't work for you, it's okay. You can just do the multiplication the way you learned through just distributing. And that will work too as long as you're distributing correctly. You will still get a correct answer. This is just a nice thing to sort of know if you can, because then you can quickly get to your product without all of the distribution.